Good morning, Biology 102. Today we're talking about the immune system and the lymphatic system. Both of these systems help protect you from diseases. I hope that you've been thinking about your immune system as COVID-19 hits the United States and all over the world. And I'm sure you have a lot of questions about how vaccines and viruses and things like that pass and work. And so save those for our Zoom meetings. Today, what I want to do is give you an overview of the immune system and really show you how the immune system is supposed to work in order to protect us from diseases. Obviously, there's some holes in our defenses that viruses and different pathogens can sneak past. So we'll be talking about that a little bit in our live Zoom meetings. But for now, I want to kind of go through the immune system and its normal function. Now, what are the differences between your innate and adaptive defenses? Usually in the immune system, when we think about the different cell classes that help protect you from disease, we group them into two camps. Either they're an innate defense or they're an adaptive defense. So I want to start and begin this lecture by talking about the differences between these defenses. Innate defenses are those defenses that operate without previous exposure to a pathogen. This is much like a one-size-fits-all t-shirt that you buy. These particular defenses, you're often born with them. They're going to work very non-specifically. That means they're going to attack anything that is non-self. Non-self are different kinds of particles and pathogens, viruses that you come into contact with that do not belong to you. So usually your cells are marked with self, right, identifiers, so that your body knows that they belong to you. And so when we're talking about innate defenses, we're talking about these kinds of defenses that are set up birth going forward. They're going to non-specifically try to attack and defend your body from different kinds of non-self particles and pathogens and things like that that you come into contact with. This is your one-size-fits-all army, right? Or your one-size-fits-all t-shirt. Adaptive defenses, on the other hand, are these defenses that are only activated by exposure to a specific pathogen. Adaptive defenses are going to be more individualized from person to person. They are more like your tailor-made army, like if you got a specific suit that is tailor-made for you. These particular cells are only activated and built when you become exposed to a different virus, bacteria, pathogen, or something in our world that can sort of build these particular classes of cells. Now, when we look at your immune system, we actually divide our immune system into 3 lines of defense that I want to walk you through. The first line over here, I like this table because it summarizes all 3 lines, but this first line is your external innate. So this is going to be external body coverings and things like that, mucus, linings that allow us to sort of keep out pathogens or keep out non-self particles. If we breach these external barriers, then you will have defenses right away that different non-self particles come into contact with. If something breaches these external defenses, then it will come into contact with your internal innate defenses. And so I want to walk you through that second line. This is considered the second line. And the third line is your adaptive defenses. This includes B cells and T cells and antibodies. These are only going to be activated when you see a specific pathogen and get exposure to specific pathogens. So you will have only built these, for example, for chickenpox, if you've ever been vaccinated for chickenpox or had chickenpox in your lifetime. If you've not seen chickenpox, you won't have actually built an adaptive defense for that particular virus, right, that we can get. Down here, you'll see the lymphatic system, so we're going to talk about that. That's almost like the battleground, the place where these particular lines of defense are stored. So let's go through the first line of defense. The first line is external innate, so you don't need previous exposure to pathogens to build this particular defense. Instead, it's something you typically are born with, and it's going to work non-specifically to defend your body against any kind of non-self particles, pathogens, toxins that you come into contact with. The first line of defense, it includes all of your external barriers. So your skin makes a very sort of consistent external surface that allows us to shed. Like if you wash your hands a lot, allows you to shed these viruses and pathogens before they can actually enter your body and then affect your cells. Any kind of orifice that is open to the external environment, like your mouth and your nose, your eyes, ears, any of these orifices will also often include a mucus lining to them to kind of help keep out and shed different bacteria. Some of these orifices have ciliated cells or hair and hair-like structures that wave out particles. Think of your nose with all the hairs that wave out particles like dust and things like that, as well as pathogens, right? Bacteria, viruses that you're coming into contact with. Things like your eyes will have tears and different solutions. Ears have waxes. There's mucus solutions. All of these solutions are often in place to help you shed those pathogens so that they cannot enter your body. If your sort of pathogens that you're around breach this external innate boundary, then it will come into contact with your second line of defense. And these include white blood cell classes that non-specifically attack anything that is non-self. So these are often lying in wait either in lymphatic tissue or in your blood, and they are waiting for different toxins, particles, pathogens to come into your body, and then they will attack them in various ways. Again, non-specifically, so they attack everything the same, whether it's COVID-19 or chickenpox, it doesn't matter. They're going to attack everything kind of in a similar fashion and very non-specifically. Like if it doesn't belong to you, they will try to attack it and destroy it. This second line includes some phagocytic cells. There are some white blood cells that basically run around almost like amoebas and engulf. They'll like extend their cytoplasm around a particular foreign material and then try to bring it in and break it down. And so these phagocytes are in your bloodstream, they're in your lymphatic system, and they try to break down any kind of non-self sort of particles that are coming into your body. Natural killer cells are also a class of white blood cells, and these they can recognize virus-infected cells, cancer cells, so they have like almost a protection against like cancer and cells that are dividing out of control as well. But rather than engulfing things that don't belong to you, they secrete some chemicals that help break down, the cell, the bacteria, the particle that doesn't belong to you. Interferons. There are some complementary sort of chemicals that are secreted by different cells and cell types to help protect you from diseases. Interferons are one of these kinds of things that can be secreted. If a virus actually enters or injects its like DNA or material into a cell, so infects a cell, then sometimes that infected cell will send off a signal, this chemical signal, these interferons that basically go to the neighboring cells and tell them to fortify their outside boundaries or their outside surfaces so that the viruses can't attack them as well. So it has a protective function for like sort of neighboring cells. Complementary proteins, there are some different proteins like your natural killer cells secrete that can dissolve or lyse, so break different kinds of bacteria, pathogens, viruses, etc. that you come into contact with. So this would also be in this non-specific class and this second line of defense. If we put those two lines together, the first line, your external innate defense, and the second line, your internal innate defense, then typically when these lines are breached, then we have something called the inflammatory response. So if you go to the doctor and they say like, oh, this is inflamed or whatever, they're talking about this inflammatory response. So how does this response work inside of your body? This diagram is working through showing what happens when a splinter comes under your skin. When a splinter or a piece of wood or something like that, you come into contact and it breaches your external innate defenses, so your skin and your external boundaries, and comes into your living cell tissue, then one of the first things that will happen is your body will secrete some chemicals. So when we sort of sense these injured tissues, one of the things that is secreted is this chemical right here called histamine. Histamine causes dilation or widening of blood vessels, and it increases leakiness of these blood vessels so that your white blood cells can exit your bloodstream, go to the site here where this splinter is or where the wound is, and these phagocytes and things like that can escape your bloodstream and then start to basically clean up. They start to engulf the non-self particles, maybe dirt and bacteria, but also things, toxins and things like that can come in to our body. When this wound finally closes, then these phagocytes either remain in lymphatic tissue or they are they clean up the area and then they get sort of brought back into the bloodstream eventually. So this release of histamine, this swelling, the leakiness of vessels, the activation of these phagocytic cells and these natural killer cells and the different complementary chemicals that they secrete in order to dissolve and digest away non-self particles is all part of this inflammatory response. Now, going to the third line of defense, the third line is your adaptive defense. So this is only activated when you have exposure to a particular pathogen. This means that this is tailor-made for you or very specific to you. If we had a classroom of people, depending on which viruses or bacteria or sicknesses you've seen in your life, your immune system adaptive defense could be quite different than your neighbor, right? The person sitting next to you. So this is very much specific to you and what you've seen in your life. This depends on some lymphocytes called B cells and T cells. B cells are made in bone marrow and specialized before they're released out into the bloodstream and bone marrow. T cells are made by your stem cells in bone marrow, but then they are specialized in the thymus. The thymus is kind of underneath the sternum area in the center part of your chest. You make about 2 trillion plus of these different B cells and T cells. You need a great diversity of them in order to be able to defend your body effectively. And so we'll be talking about these particular kinds of cells. I want to walk you through first the differences between the two classes of cells. So B cells, they are going to participate in something called the humoral immune system response. And one of their big jobs is they have these Y-shaped chemicals on their outside surface. And these Y-shaped chemicals can be released. And these Y-shaped chemicals actually become antibodies. And antibodies, what their main function is if you have an antigen running around your bloodstream, the antibodies actually tag, they dock and lock key style around the antigen or the foreign material. And these antibodies can then almost like tag invaders for destruction. They can slow them down with this antibody locking system. Sometimes they clump them in your bloodstream, so it's easier for your other cells to kind of find them and then deal with them. So B cells really participate in this making of antibodies which mark our invaders or these antigens, these pathogens, and foreign materials for destruction. T cells participate in something called the cell-mediated immune system response, and they often are presented with new things that you've never seen before, so new pathogens, things of this nature, and then they actually can mount an attack and secrete some different chemicals to actually destroy invaders. And so we'll kind of talk through that. One of the biggest classes of T cells are called cytotoxic T cells, and they release a chemical that breaks down the outside surfaces of different pathogens so that the cells and the viral capsids and things like that break down so that you no longer sort of have that pathogen in your bloodstream. So they can actually attack and destroy invaders. Now, I've been using this word antigen. It's really hard not to use these terms before we kind of define them. But antigens are any particle that gets a response from your lymphocytes. Typically, these are foreign materials, so virus, pathogens, bacteria, etc. But they can also be things that your immune system should be ignoring. So lots of people with allergies actually are treating something like pollen as an antigen. And these are often called allergens because they're a class within this antigen sort of class. And so it's a way that your body's incorrectly sort of attacking things that it should be ignoring, but incorrectly attacking them instead. Now, B cells and T cells are specialized with antigen receptors on their surface, and so that means they can only dock and bind to one kind of antigen. That means each B and T cell can only recognize one specific antigen and deal with it. And that's why you need so many different kinds and numbers of these B cells and T cells. You need them existing in your body so that when different kinds of pathogens come along, or toxins or things that can get a response in you, then you have a group of these cells that are able to attack and defend your body. Now, I want to walk you through an overview of how the adaptive defenses work. So again, we're on this third line, these B cells and T cells, and this shows a flow chart of kind of how your body will deal with different foreign materials and things like that, antigens coming into contact with your internal cells. Now, up here at the top is your first sort of primary exposure, and then down here, we have our secondary exposures. And your body's going to act differently when it's seen something before, right? And so let's talk through the first time you see something. The first time you see something, if it's something that you've never seen before, and it's got a very different, maybe it's a virus with a very different outside external protein coat, or maybe it's a toxin that you've never seen that a bacteria is secreting and you've never seen it before. Oftentimes, what will happen is your phagocytes that engulf those cells, right? So engulf them, bring them in, will actually engulf these pathogens and then display on its outside surface what the outside surface of the virus that needs to be destroyed, or the bacteria is that needs to be destroyed. These are called presenting cells. So they present the antigen, what that antigen looks like chemically on the outside surface of their cell. And these antigen presenting cells often will present to a helper T cell. And notice how this helper T cell is kind of the middleman in this flow chart. So the helper T cells then almost learn. The presenting cell presents here, let's deal with this, right? Let's destroy this. And so these helper T cells will dock and bind to those presenting cells. And then they will then stimulate not only cytotoxic T cells to produce a chemical that can break down anything with that antigen in your body. But the helper T cells will also activate your B cells and tell them to secrete antibodies to find that specific antigen and then lock it down, right, with that Y-shaped antibody chemical. So lock it down so that, again, it clumps and tags and marks invaders for destruction. Now, if you notice, this is your primary response, and oftentimes this takes a few days for your body to not only your presenting cells to present to the helper T cells, but the helper T cells to also activate all these other lines along here, so your B cells and your cytotoxic T cells, so that you can deal with this pathogen. Because this takes a number of days, let's say 4 or 5 days, you get sick. You oftentimes get a fever. Your body sometimes can have different, reactions, rashes, things of that nature, in order to sort of get through this original presenting phase. This primary exposure means that sometimes you get sick in this phase when your body is trying to activate these lines. And sometimes those sicknesses are quite dangerous, right? The fevers, rashes, or other sort of chemical reactions that are going on in your body can be quite dangerous. So one of the things that you do in your body to help you speed up not only the force and the speed at which you produce these cells, but also the strength and the numbers of cells you produce, is to leave behind memory cells. You not only leave behind memory T cells, helper cells that will sort of activate more quickly the lines, but you also leave behind memory B cells that can create antibodies quite quickly a second time, and some cytotoxic T cells that can actually break down and destroy those antigens that it comes into contact with. If you get down to the secondary exposure and you've already seen something, you get to skip all of this other stuff up here and go straight to secreting antibodies, destroying the antigens in your bloodstream as they come in. This means that sometimes you don't even get symptoms, right? So the second time you see something, if you have these memory cells in place, your immune system works so strong, so fast, that you don't even get the fevers, you don't get the rashes, you don't get the reaction that you would normally get with that primary infection. This enables us to sort of create these memory cells and then not get a disease a second time, right? So we don't actually get the symptoms or the dangerous bits of those diseases. Now, memory cells are really at the heart of why we create vaccines. So vaccines are harmless variants of a disease-causing microbe or one of its parts that helps our defense cells, these B cells and T cells, gain these memory cells so that our responses and our attacks are much more quick and much more strong the second time around, in hopes that we don't even get the symptoms, right? So if we have these memory cells or sometimes pre-made antibodies, things of this nature in place, then we can mount a much quicker and stronger defense the second time. Vaccines, when they first got started, sometimes they were attenuating organisms or slowing down organisms, either by putting them around chemicals or killing them, or just slowing them down in various ways, like keeping them refrigerated before they gave a particular vaccine to people. These kinds of vaccines then allow your immune system to take this slowed down or dead version of a virus or a pathogen and then learn what that outside coat is and leave a memory cell behind. Nowadays, a lot of our vaccines are genetically modified. So if we know a gene for like hepatitis or something like that, and we can build restriction enzymes to cut out maybe the surface of what that hepatitis B looks like and move it into a non-pathogenic cell that displays that external surface, then we can then build memory cells from these genetically modified sort of vaccines or these non-pathogenic cells. And that's a very safe way to sort of build a vaccine, because you can't get sick. You can't get the actual sickness from the vaccine. Instead, you're just showing and displaying an outside surface, almost like a mugshot, so that your immune system cells can memorize what that mugshot looks like, so that when it sees the invader, it can attack more quickly the second time. Now, I've only mentioned a couple of times the lymphatic system. The lymphatic system is a group of vessels and tissues that run alongside your bloodstream. And the lymphatic tissue has a couple of different jobs. One of them, it helps clean up our blood. So there's lots of lymph nodes, so collections of almost like pockets in this lymphatic tissue. And so the spleen, one of its main jobs, one of the organs here, is to actually clean blood and then take out old red blood cells, white blood cells, and replace them and kind of make sure there's nothing in blood that doesn't belong, right? But the second thing that kind of connects with your defense system is that a lot of this lymphatic tissue, lymph nodes, also house white blood cells. So it's almost like a place to put your army. And I say up here in my title that the lymphatic system is kind of like your battleground. A lot of times when swelling and things like that happen, it's these lymph nodes that are swelling and releasing these white blood cells. And so it is a space where the actual infectious agents are being targeted and then also engulfed and digested away and things like that. So it's almost like the place where the battle between the antigens and your adaptive defenses and your defense cells goes down. So your lymphatic tissue, a couple of different jobs. One is cleaning up sort of and replacing these cellular elements, but also housing these white blood cells so that we have a number of these white blood cells to attack swiftly and strongly these pathogens and antigens that enter our body. Now, that's all I want to say. It's a quick introduction about your immune system. Your assignment for our Zoom meeting is to look over this immune system sheet. It goes through the 3 lines of defense and then also some problems with this defense. So I will see you next time. Have a great day.